Welcome to a high-stakes AI-powered tech debate, where two advanced AI-trained models go head-to-head on one of the most enduring questions in computing history. Which operating system is better, Windows or Linux? On one side, we have Model Joe, a seasoned Windows advocate deeply rooted in the user experience and enterprise familiarity that Windows offers. Representing the voice of power users, businesses, and gamers, this model will present a compelling case for why Windows remains the dominant choice. Facing off is Model Bob, a dedicated Linux developer who once walked the halls of Windows but now swears by the freedom and flexibility of Linux. Drawing on deep-rooted experience in open-source development and system customization, this model champions the Linux ecosystem with technical clarity. The debate will unfold across 5 critical points: system performance and resource usage, security and vulnerability exposure, software and application compatibility, customization and control, ease of use and learning curve. After each round, both arguments will be evaluated and rated on a scale of 0 to 5 by 5 independent, unbiased AI systems, each trained to assess clarity, technical strength, and overall relevance. Let the debate begin. System performance and resource usage.
The Windows is bloated narrative is outdated propaganda from the XP era. Modern Windows runs a hybrid microkernel architecture that's fundamentally more sophisticated than Linux's monolithic approach. Here's why this matters: thread scheduling supremacy. Windows 11 Scheduler uses machine learning algorithms to predict application behavior and optimize CPU allocation dynamically. The scheduler understands application priority contexts that Linux's Completely Fair Scheduler (CFS) treats as generic processes. When you're running Visual Studio while streaming and gaming, Windows intelligently boosts the foreground application's priority. Linux treats everything equally, creating perceptible lag. Memory management mastery. Windows memory compression feature can compress up to 40% of system RAM in real time using hardware acceleration. Linux users manually configure ZSwap and struggle with swap partition optimization, while Windows handles this transparently. The Working Set Manager dynamically adjusts memory allocation based on actual usage patterns, not theoretical algorithms. I/O performance reality check. Direct storage bypasses the traditional storage stack entirely, providing sub-millisecond storage latency for NVMe drives. Linux's IO_Uring is impressive for servers, but Windows Store and DI framework provides hardware-accelerated storage virtualization that Linux can't match without kernel recompilation and driver hell. Performance monitoring. Windows Performance Toolkit, WPT, and event tracing for Windows, ETW, provide nanosecond precision profiling across the entire system stack. Linux's perf tools require extensive knowledge and give you fragments. Windows gives you the complete picture.
Linux is a lean, mean performance machine. Unlike Windows, which often comes bloated with pre-installed software and background processes, Linux distributions like Arch, Debian, or even lightweight options like Alpine are engineered for efficiency. A minimal Linux install can run on as little as 128 MB of RAM. Try that with Windows 11, which demands 4 GB minimum and still chugs on budget hardware. Linux's modular design lets you choose your kernel, init system, systemd, OpenRC, or runit, and desktop environment, or none at all. This means you can strip it down to bare essentials or optimize for specific workloads. For example, Linux's scheduler, CFS, Completely Fair Scheduler, is ruthlessly efficient, balancing CPU tasks with minimal overhead. Windows, by contrast, often prioritizes user-facing responsiveness at the cost of background process efficiency. On servers, Linux dominates. Think Apache, Nginx, or containerized workloads with Docker. It's no coincidence that 96.3% of the top 1 million web servers, W3Tech's 2025, run Linux. My own experience running a home server on Ubuntu with ZFS for storage and KVM for virtualization shows Linux handling heavy I/O and multitasking with ease, where Windows would buckle under resource contention. Linux's low-latency kernels, like preempt_RT, also make it a darling for real-time applications, from audio production to robotics.
Security and vulnerability exposure.
Linux security through obscurity is a dangerous fallacy. Windows implements defense-in-depth strategies that make successful attacks exponentially harder. Hardware security integration. Every Windows 11 system requires TPM 2.0 and secure boot by default. This isn't optional configuration, it's mandatory architecture. Linux distributions still ship with these features disabled because more freedom. The result? Windows systems have cryptographically verified boot chains, while Linux systems remain vulnerable to firmware-level attacks. Kernel protection superiority. Kernel control FlowGuard, KCFG, prevents ROP job attacks at the processor level. Hypervisor-protected code integrity, HVCI, runs kernel integrity checks in a separate hypervisor partition, making kernel exploits nearly impossible. Linux's KSLR and SMAP are primitive compared to Windows' virtualization-based security, VBS architecture. Application isolation excellence. Windows Defender. Application Guard runs Edge in a hardware-isolated Hyper-V container. Every suspicious website runs in a disposable virtual machine. Linux's FireJail and similar tools are user space solutions that kernel exploits can bypass. Windows uses Type 1 hypervisor isolation, real-world vulnerability response. Microsoft's Security Response Center, MSRC, processes vulnerabilities through a unified pipeline with monthly Patch Tuesday releases. Linux users wait for individual maintainers across hundreds of projects to maybe patch their specific distribution. Windows users get comprehensive security updates. Linux users get fragmented, inconsistent patches. The enterprise reality? Windows Hello for Business integrates with smart cards, biometrics, and FIDO2 tokens through a unified API. Linux desktop environments can't even agree on a single authentication framework.
Linux is a fortress. Its open-source nature means thousands of eyes scrutinize the code daily, catching vulnerabilities faster than Microsoft's closed-source ecosystem can. The Linux kernel's privilege separation, enforced through mechanisms like Selinux or Apermore, ensures processes run with least privilege by default. Compare that to Windows, where UAC, user account control, is more of a speed bump than a barrier, and legacy code leaves gaping holes. For example, SMBv1 exploits like WannaCry. Linux's package managers, apt, DNF, pacman, deliver security updates within hours, not weeks. For instance, when CVE 2024-1086, a kernel use after free bug hit, Debian and Ubuntu patched it in days, while Windows users often wait for Patch Tuesday. Linux's diversity, multiple distros, kernels, and configurations makes it a moving target for attackers. A zero-day hitting Ubuntu might not affect Fedora or Arch. Windows? One size fits all, and one exploit can cripple millions. I've hardened my own systems with custom iptables rules and fail2ban, blocking brute force attacks in real time, something Windows Firewall struggles to match without third-party tools. And let's not forget, Linux rarely needs antivirus, while Windows is practically married to Defender or third-party bloatware.
Software and application compatibility.
This isn't even debatable. Windows wins by orders of magnitude. Professional software dominance. Adobe Creative Cloud, Autodesk Maya, SolidWorks, Final Cut Pro alternatives. Professional audio workstations, they're all Windows native with full GPU acceleration and hardware optimization. Linux alternatives like GIMP and Blender are hobbyist tools compared to industry-standard professional software that generates actual revenue. Gaming performance leadership. DirectX 12 Ultimate with features like variable rate shading, mesh shaders, and direct storage provide gaming performance that Linux's Proton compatibility layer simply cannot match. You're running Windows games through translation layers, while Windows runs them natively with full hardware optimization. Binary compatibility legacy. Windows maintains backward compatibility across decades. Software written for Windows 7 runs on Windows 11 without modification. Linux breaks user space constantly ask any developer who's tried maintaining software across Ubuntu LTS releases, Enterprise Integration Reality, Microsoft Office 365, Active Directory, Exchange Server, SharePoint. The entire productivity ecosystem is Windows optimized. LibreOffice can't even render complex Excel spreadsheets correctly, and don't get me started on trying to maintain formatting compatibility. Development environment superiority. Visual Studio remains the most sophisticated IDE ever created. IntelliSense, debugging tools, profiling integration, and Azure DevOps integration create development workflows that Linux developers piece together from dozens of separate tools.
I'll concede that Windows has an edge in commercial software. Adobe, Microsoft Office, and AAA games still favor it. But Linux has come a long way. Tools like Wine and Proton, via Steam, let me run Photoshop, Excel, or even Cyberpunk 2077 with near-native performance. For developers, Linux is paradise. Native support for Python, Go, Rust, and container tools like Podman outshine Windows WSL2, which is essentially Linux in a VM pretending to be native. Open source alternatives like GIMP, LibreOffice, and Blender are robust. And for niche needs, I can compile software from source, tailoring it to my hardware. Package managers are Linux's killer app. A single sudo apt install or pacman-s pulls in dependencies cleanly, unlike Windows manual installer hunts or Wingit's inconsistent ecosystem. For server workloads, Linux is unmatched. Think PostgreSQL, Redis, or Kubernetes. My own dev environment on Arch with NeoVim and custom bash scripts is a productivity beast that Windows clunky PowerShell can't touch. Sure, some proprietary software skips Linux, but the open source community's pace of innovation, for example, OBS Studio, Kdenlive, often outstrips commercial offerings.
Customization and control.
Linux uses mistake configuration complexity for actual control. Windows provides deeper system control through more sophisticated interfaces. Registry power. The Windows registry is a hierarchical configuration database that's fully documented and programmatically accessible. Every system behavior can be modified through well-defined registry keys. Linux's scattered text files across /etc. are inconsistent, poorly documented, and break between distribution updates. Group policy granularity. Group Policy Editor exposes over 3,000 configuration options through a coherent interface. Want to control USB device access, network adapter behavior, application installation permissions? It's all there with centralized management and inheritance models. PowerShell supremacy. PowerShell 7 is object-oriented automation that makes bash scripting look primitive. CMDLets return net objects, not text streams. Desired state configuration, DSC, provides infrastructure as code capabilities that Linux users cobble together from Ansible and custom scripts. Driver architecture excellence. Windows Driver Model, WDM, and Windows Driver Framework, WDF, provide stable ABI API contracts for hardware vendors. Device manufacturers can write one driver that works across Windows versions. Linux's constantly changing kernel interfaces mean hardware support is a moving target. System monitoring sophistication. Performance counter architecture provides real-time telemetry for every system component. Event tracing for Windows ETW offers kernel-level instrumentation with nanosecond precision. Linux monitoring tools are fragmented across different subsystems with inconsistent interfaces.
Linux is the ultimate playground for tinkerers. Want a desktop that looks like a sci-fi dashboard? Install i3, BSPWM, or Hyperland, and script your workflow to perfection. Need a custom kernel for your obscure hardware? Grab the source, tweak config_preempt, and compile. Linux's open nature hands you the keys. Every file in /etc., every systemd unit, every shell script is yours to mold. My own setup, with a custom grub config and a patched DWM window manager, is tailored to my exact needs, from key bindings to memory usage. Windows? You're stuck with Microsoft's vision. Registry tweaks are a nightmare, and telemetry is practically inescapable without hacks that risk breaking updates. Linux lets you disable telemetry entirely. For example, comment out Canonical's data collection in Ubuntu. Distro choice alone, Arch for bleeding edge, Debian for stability, or Gentoo for ultimate control, gives Linux unmatched flexibility. I've automated backups with rsync and cron, something Windows Task Scheduler struggles to match in simplicity. Linux isn't just customizable, it's yours.
Ease of use and learning curve.
Ease of use isn't about dumbing things down, it's about removing friction from productive work. Consistent user experience, Windows, common controls and WinUI framework ensure applications behave predictably. Linux desktop environments fragment between GTK, Qt, and various toolkits, creating inconsistent experiences where keyboard shortcuts and interface conventions vary randomly. Hardware support excellence. Windows includes over 600,000 device drivers in the default installation. Plug in any hardware device and it works immediately with full feature support. Linux users compile drivers, search for firmware blobs, and deal with partial hardware functionality. Update management sophistication. Windows Update handles drivers, security patches, feature updates, and application updates through a single tested pipeline. Linux users juggle multiple package managers, manually update drivers, and pray that kernel updates don't break their custom configurations. Enterprise workflow integration. Single sign-on SSO through Azure Active Directory, seamless Microsoft 365 integration, BitLocker encryption that's transparent to users but cryptographically robust. Linux desktop environments require extensive configuration to achieve basic enterprise functionality. Troubleshooting superiority. Event Viewer provides comprehensive logging across all system components. Performance Monitor offers detailed telemetry. Resource Monitor gives real-time system insight. System File Checker can repair corrupted system files automatically. Linux users piece together information from scattered log files and hope someone documented the solution on Stack Overflow. The bottom line, engineering reality versus ideology. Windows represents decades of engineering investment focused on real-world productivity. While Linux enthusiasts debate the philosophical purity of open source, Windows delivers hardware optimization that utilizes every CPU core and GPU shader efficiently, security architecture that assumes hostile environments and defends accordingly, software ecosystem that enables professional work and revenue generation, system reliability that enterprises trust with mission-critical workloads, user experience consistency that reduces cognitive load and maximizes productivity. The market has spoken. Windows dominates desktop computing because it solves actual problems rather than satisfying ideological preferences. When your livelihood depends on getting work done efficiently and reliably, Windows is the obvious choice. Linux has its place servers, embedded systems, and hobby projects. But for professional desktop computing where performance, compatibility, and productivity matter more than license purity, Windows remains architecturally and practically superior.
Linux's learning curve is real, but it's a feature, not a bug. For newbies, distros like Ubuntu, Linux Mint, or Pop! OS offer polished GUIs that rival Windows plug-and-play feel. Point-and-click software centers, driver auto-detection, and DEs like GNOME or KDE make Linux accessible. But the real power lies in the CLI. Learning Bash or ZAH is like learning to code. Steep at first, then liberating. I can grep logs, find files, or resync directories in seconds, tasks that take minutes in Windows' clunky Explorer or PowerShell. Windows feels easier because it hides complexity, but that's a trap. You're at Microsoft's mercy for updates, drivers, and bloatware. Linux empowers you to understand your system. My first distro hop from Ubuntu to Arch taught me about bootloaders, fstab, and xorg, knowledge that made me a better sysadmin. For non-techies, Linux's user-friendly distros are now so polished that my grandma could use Linux Mint for browsing and email without noticing it's not Windows. The community, think Arch Wiki or Ask Ubuntu, offers better support than Microsoft's forums, hands down. Finally, Linux isn't just an OS, it's a lifestyle of control, efficiency, and freedom. It outpaces Windows in performance, sipping resources while Windows guzzles them. Its security model, built on transparency and rapid patching, makes it a fortress where Windows is a sieve. Software compatibility is no longer a deal breaker, with open source tools and compatibility layers closing the gap. Customization? Linux is a canvas. Windows is a coloring book. And while Linux demands you climb a learning curve, it rewards you with mastery, not dependency. As a longtime Linux user, I've built servers, scripted workflows, and customized environments that make my workflow sing. Windows feels like a walled garden. Linux is the open wilderness. For anyone who values performance, security, and the thrill of owning their system, Linux isn't just better, it's the only choice that respects you as a user. Join the revolution. Boot a live USB. You'll never look back. And at day